Some microphone difficulties with this device, but our guest has got a mic on which should work and should make it possible for you to hear what he has to say this evening. I'd like to welcome you to the next event of Enrichment Week. It's my pleasure to have the opportunity to introduce our speaker. Having our guest here this day and through tomorrow, and actually the weekend before he heads north to visit his family in Elkhart, Indiana, is kind of a nice old home week for a lot of faculty and staff here at the college. Our guest is, of course, a graduate of the College of Architecture and Planning. In fact, he was in the first graduating class. You're more familiar with two of his colleagues who went through the program with him and graduated at the same time. One is on a tour around the world right now. His name is Underwood. And the other one's sitting right down behind our guest. His name is Eggink. Both Hari and Rod were in the class that initiated the program here at the College of Architecture and Planning a couple of years back. That was a joke, a couple of years back. It's my pleasure to introduce tonight Michael Holtz. Michael is the president of the Architectural Energy Corporation. This is an energy and environmental research, development, and consulting firm located in Boulder, Colorado. Michael's a leader in the areas of architectural and energy-related research and development. He's managed solar energy programs, including that of the International Energy Agency projects in passive solar design and the application of energy analysis tools. He spent a brief time directing programs at the National Renewable Energy Lab, which then was called the Solar Energy Research Institute. He has created innovative projects and software, tools such as REM-Rate and REM-Design. These are used here in the state of Indiana for the Energy Efficient Mortgage Program, the home energy rating system that's used throughout the state, and in fact exists throughout the country. He also has developed through his firm the micro data logger data acquisition system, which serves some of their purposes as they engage one arm of their professional application, which is to commission buildings once they've been designed and constructed. We're really fortunate to have our guest with us tonight. Michael received in 1983 the Ball State University Alumni of the Year Award, and since that time he's maintained good connection with the college. He comes back on occasion. And tonight we had the great pleasure of hearing him talk about alternative careers in architecture. Please join me in welcoming Michael Holtz.
Am I alive? I can probably talk loud enough so you may not need this. If it's a problem, let me know. But I certainly appreciate the opportunity to participate with all of you in Enrichment Week, and I hope all of you are taking advantage of the opportunities that this week is providing you. I was thinking at dinner, the college has a tradition of this kind of innovative event. When Harry and Rod and I were here, we had a couple of very interesting opportunities during our stay, including Peter Hausman, who was here with a cities planning game we played on a mainframe computer at the time, and Nicholas Negroponte was here talking about computers and architecture. And if you know Nicholas Negroponte, he's the leader in some of these robotics and other computer applications at MIT. And we had our famous Monday night lecture series that we all had to attend, but it was certainly well worthwhile. So thanks for attending this presentation. I hope you take advantage of all the other events that are occurring during Enrichment Week. The task I've been asked to address is really an interesting one to me. It's alternative careers for architects. And I imagine they've asked me to do that because my career certainly hasn't followed traditional paths in architecture. Although hopefully, as you'll see during my discussion, that I am intimately involved in things that are important to the quality of the built environment. And that's why I've chosen a particular way to go about offering my contribution to improving the built environment and improving mankind. It's not a topic that lends itself to great slide presentations, though. It's like alternative careers in architecture. What do you show about that? So I'll try to intersperse it with some slides of some work and things we've done that will hopefully keep you all awake. I think some background's in order to kind of set the framework for this presentation. Some of it is on the personal side. As Bob Kester said, I am a Hoosier, born and raised in Elkhart, and proud to be a Hoosier. I am a graduate of this college, and proud to be a graduate in the first class, 1971. So it seems like a long time ago, and I'm sure Harry feels the same way I do. Most of you probably weren't alive when Harry and I graduated from this institution. But it was an exciting time from 1966 to 1971. It was a very challenging time, and I hope your times are as interesting as ours were in the 60s. And most importantly, well, I should tell you, I'm a registered architect, a member of the NCARB, and also on the AIA Board of Directors for the Northern Colorado chapter of the AIA. So even though I have an alternative career in architecture, I'm still involved in the Membership Association of Architects. And lastly, importantly, I play third base on the Boulder Red Sox Men's Senior Baseball League, an occasional pitcher. Okay. So I can still hit the fastball. Some other background might be useful too, just to tell you something about how I've spent my last month. And this will give you some flavor about alternative careers that are architecturally related. I started out the month of March by taking a week's trip to Yamagata and Tokyo in Japan. And I was there to assist an industry association of architects and home builders and equipment manufacturers and utilities to develop a sustainable housing program. They wanted to know how they could introduce environmentally friendly housing to the Japanese marketplace. And the U.S. has a number of programs that do this, and we're involved with a number of them through my company. And so they invited me to come advise them on how they could create such a program for their implementation in Japan. So that was kind of a week, and I was in the snow. It snowed constantly in the mountains of Yamagata, but we had very good meetings, and I think they're off to a good start to creating a sustainable housing program for Japan. When I returned from that trip, the second week of March was really spent with several different things. One was we were part of a winning design competition for a 600,000 square foot, $124 million City of Denver office building. It was a very interesting design competition that we were on the winning team, and now they're starting to finalize the design, so I was really working with them to figure out how to integrate sustainable building practices and daylighting techniques into this large facility and achieve the level of performance that the City of Denver required. Also had a meeting with a patent lawyer about a daylighting product we've invented, and we're applied for a patent so that it'll make it easier for the design profession to integrate daylighting into commercial facilities. And so we had a meeting with the patent lawyer to go through some patent examiner comments on our application, and then we had a meeting with a company we're working with to further develop this product and put it into commercial form so it would be available on the marketplace. That was pretty much, and then running the office was part of it, the second week. The third week, I had a trip to Madrid, Spain. We have a project that I manage with the International Energy Agency, which is concerned with how to reduce dependence of the building industry on non-renewable energy sources. And I'm managing an 8-country project that's trying to develop better analytical tools for evaluating the performance of solar buildings. So the meeting in Madrid was to review the research we've been working on to create a new generation of tools that are based on object-oriented simulation environments, rather than what we call monolithic simulation tools, like DO2 or BLAST or some of these tools you may be exposed to, or even REM, our software. We're also developing ways of testing tools. How do you know as a tool is accurate? If people are going to use these tools, architects, engineers, home builders, how do you know that tools give you accurate results? So we've been developing a suite of tests that you can put these tools through that tell you if they're giving you accurate results and that the math and the physics are properly being handled in the software. So that was week 3. Week 4 had to do with a whole series of things. We have a project in the office where we're developing wireless data acquisition. That is, how can you monitor the performance of a building to know how the mechanical equipment's performing, what kind of comfort's being maintained, what the energy use is of the building, and how can you do that very efficiently at low cost or on a temporary basis. So we've been trying to develop a whole generation of wireless data acquisition devices that you could place around the building at key points, like air handlers or the chillers and boilers and so on. And that data would wirelessly come back to a central node, and that central node could then be connected to the internet, and at some distant point you could acquire that data, analyze it, and understand how the performance of that building is happening. And then if you have to make corrective actions to get the thing back in line, or if comfort's not being maintained. So that was part of the week, the 4th week. Then we had a meeting with people from the Gas Research Institute. We've developed a software package for doing distributed generation. That's like using microturbines, or reciprocating engines, or fuel cells, or photovoltaics to generate power for buildings, but do that power generation locally at the site of the building. So we've developed some software that screens those technologies to tell you if it's economically feasible to install distributed generation at the building as opposed to buying electricity off the grid. So we had prepared a business plan for how we're going to commercialize this software product. So that was week 4. You're probably wondering, what do all these things have to do with architecture and education and how they might change or alter your career paths? And I'm going to try to get into that during the remainder of this discussion. But what I'd like to step back for a moment is think about what are the skills that architects acquire during the course of their education, what you're going through right now. What are the kind of the fundamental knowledge that you're acquiring now that will have some usefulness for you as you go into your careers? I've kind of broken them down into 3 general areas. One I call fundamental knowledge. And it's kind of the basis for other kinds of events. Fundamental knowledge are things like understanding physics, material, statics and strengths, mechanical, electrical systems, structures, design. These are kind of fundamental points of knowledge that you acquire during some of the courses I'm sure you all hate. But they're very essential to your ability to function in a very difficult, competitive, complex marketplace. The second group of knowledge I call process knowledge, and that consists of the following. One is the ability to gather data, pertinent data, and analyze it so you transform it from data to information that you can make some decision upon. You also learn how to synthesize, whether it's urban design or whether it's architectural design. How do you take that fundamental knowledge and use it to create whole new ideas and synthesis of form? And you really learn decision making. That's a process knowledge. How do you go through the process of defining evaluation criteria, developing alternative solutions, evaluating those solutions, deciding what's the best options, and then implementing those. So that's the second kind of category of knowledge and skills that you are developing and acquiring through your education in architecture school. The third is very important, and you use it your entire life, but certainly in architecture school you get a lot of it, and that's communication skills. You certainly have to know the graphic side, both on hopefully hand-based methods, drawing. Hopefully you still know how to draw. That's real important. We should talk about that sometime. My son's an artist, and I think all art schools want people that can draw, particularly figure drawing. Next is physical models. Hope you're still building physical models. They're always very useful because you'll find many people still don't understand drawings or even computer-based, computer-generated photorealistic renderings of space. And hopefully you're developing verbal skills through critiques and other things and projects you have, and written skills. So communication skills are very important in architecture and just in general for whatever career path you take. What's interesting about architecture, though, is that those three general areas of skills are developed within the context of constant problem-solving exercises. From the first day you come into architecture schools until you leave, you're always using those things in problem-solving settings, typically in the studio, but also in many other opportunities. And that's somewhat unique if you look at the different professions. So you're being asked to think, to really apply that knowledge in problem solving. And that is really the key to your education, which is really the ability to think clearly and think soundly and then act upon that result from that thinking and thought process. And that's kind of the key to then deciding or even having the opportunity to have alternative career paths with your architectural education, is that ability to think. And I think that's what Carol is after, trying to get you to this Enrichment Week is all about. It's getting out of the box, literally and figuratively, that you're in, and thinking about how these sets of skills that you are acquiring can be used in other kinds of ways that you may not even thought about. We had a course when I was here fifth year. I don't know if you still have it, but it was called Architectural Philosophy, or Philosophy of Architecture, and Professor Wyman taught it when we were here. And it was a course designed to review the architectural theories of world-renowned architects and planners. So we looked at Frank Lloyd Wright and Mies and Cabru and all the great designers, and talked about and read their work, and just to kind of understand what is the basis that they espouse that results in whatever the result is that comes out of their actions. And I remember we had a final exam, and Professor Wyman asked each of the students in the class, and at that time it was just the remaining 35 of us from the first class, and he asked us to write an essay that described our philosophy of architecture. And at the time I thought that was really quite humorous, because we were just naive people trying to get through architecture, and we were up all night trying to get our thesis work done, and he asked that question, and we were still in our formative stages of understanding. We hadn't been out practicing professionally, so I assume he was just trying to test us and where our heads were at that point in time. And so I was thinking about it, and I just didn't know how to respond, so I finally wrote down on a piece of paper, my philosophy of architecture is to make people happy. Signed my name and handed it in, walked out the door. It made for a quick final exam. I think I left my fellow classmates and Professor Wyman in a quandary to some extent. He probably started wondering about my future prospects in the world of architecture. And I think he actually probably gave me an F in the class. Well, not for that test, I think. I'm not sure. I mean, he probably did. He was a pretty serious guy. But it didn't bother me at all, because it's a philosophy I still believe in. and I've really followed that philosophy in the career path I've taken with my life. And I think, as opposed to then when I had very little reasoning behind that statement, I think I have better reasoning now behind that statement in terms of the philosophy of architecture to make people happy. And I think that kind of thinking can allow you to choose a variety of different career paths to do that. There is not one path that says you have to go out and design buildings to make a contribution to improving the built environment. There's lots of different ways of doing it, and hopefully you're getting some exposure in your education, in your employment, and in what you read and learn in other parts of the university about those opportunities you have to make that contribution. Okay, next piece of some kind of introductory remarks here. What I've come to learn over, what is it now, 29 years, I guess so, 71, since leaving this fine institution of higher learning, is that architecture is about performance. Architects are in the performance business. And maybe you haven't thought about it in that context. You know, what is this guy saying? Performance. I mean, certainly you all know about functional requirements and that the functional needs of the users that are housed in buildings. I mean, that's pretty basic. But you're also concerned about health and safety of the occupants. You should be concerned about the productivity of those users and occupants, protection from the climate that surrounds that facility, comfort, the sustainability of that facility, so that the resources you use don't prohibit future generations from also having high quality of life on the planet, indoor air quality, and even psychological, spiritual aspects. Architecture and planning should really create a sense of awe and joy and other emotional kind of responses to the spaces, both interior and exterior, that you create. So architects really have a responsibility to provide the required levels of performance within the constraints of time and money, site, and many other factors that you have to deal with to generate form and design. Now, that's what my life has been devoted to, is really to provide or help others develop high-performance, man-built environments that are energy and environmentally responsive. I think this generation, more than maybe previous generations, but certainly this generation, has a key role to help create a sustainable future. The things that have been done to this planet in the name of progress over the last 100 years have really put us all in a deep hole. And it's going to take many of you and many of us working together to solve some of these problems. I won't get into the whole environmental spiel, but you know it. We've got problems that we need to address, and you will have to make value judgments in your work about how you address those. Do you just say, well, it's not important on this project, I'm not going to worry about it, let's move on? Or are you going to make a professional, like a personal value judgment that it's important that you respond to it in everything you do? So, I think, in short, you know, the goal I have in my professional career has been to make people happy. And what I'd like to do is just provide a few examples of what I've been trying to do, because I can talk about alternative careers in architecture best by telling you something about my career, because I don't want to just theoretically talk about, well, you could get a degree in architecture and be a rock musician. That's an alternative career, I guess. There's lots of things you could do with your life, and you'll have to decide for yourself based upon what passions you have and what motivations you have, and most importantly, what opportunities you have. because the opportunities that will help shape your career are going to come from the most crazy places in your life, and then you'll have to decide if that opportunity is something that fits within what you want to do with your life. So this is the growing up story. When I was growing up, my best friend was a boy by the name of Tom Keene. And the old folks around here know Tom Keene, and Tom's dad was an architect, and it was called Keene McRae, and McRae was an engineer. And when Tom and I were growing up together, he was going to be the architect and I was going to be the engineer. And as it turned out, I became the architect and he became an insurance salesman in southern Michigan. but it was because of that love of building. You know, that's what gets us all turned on. We like to go out and see something happen. We like to see something get built. And you go, wow, that's cool. And that kind of leads us into thinking about something in building. And, hey, architecture sounds cool. Also, I had the opportunity to work for Tom, my friend Tom's dad, as an office boy in high school, as the office boy, making copies back when they had these god-awful ammonia blueprint machines that would damage brain cells left and right, man. It was nasty. And I worked summer construction jobs, so we got a chance to do that. So that's probably where a lot of us came from. You know, they got us turned on to architecture as something that we might be interested in as a career in our lives. Okay, college. What do you do during college? Well, you do what you guys are doing. You know, have to come to these lectures and have studio problems and deal with structures, and reinforced concrete, and all that good stuff. But during those summer periods, and I hope all of you do lots of interesting things, I had some interesting opportunities. I worked for the Elkhart building department, doing plan checks, looking what other people design and put in front of you to see if it's in compliance with the city building code. Sounds pretty boring, but you'll learn a lot about how things go together and what's safe and what's not safe doing that. I also had a chance to work for the city engineer's office, helping lay out water and sewer lines. Pretty mundane thing, but got me into surveying and reviewing construction and digging a lot of holes. Then I also was working in architects' offices, both in Indiana and then in Connecticut. Got a chance to go out of state and work in a number of firms, and it was a pretty exciting time to be out there. That was in 1969, and I got a chance to go to Woodstock, so that was pretty cool. And then I also had a chance to work in a city planning office. So I had an opportunity to see how planning was done. And I got a chance to work with the FAA to help lay out a flight zone for a new airport into Elkhart. And that flight zone had all kinds of three-dimensional zoning issues that you had to deal with because you couldn't build certain things in certain areas and so on. So I got to work a lot with FAA in Chicago office to figure out how to put together this three-dimensional zoning ordinance. So that was a pretty interesting set of activities that I got a chance to look at not from an architect's perspective, but some other perspectives that you could use architectural education for. So all those represent, obviously, alternative career paths. After college, did what most of you probably do. I went and worked for an architect, Enfield Zents up in Elkhart. Ray Enfield's still around. I don't know too about Zents, but our specialty was humans and critters. So we did a lot of animal hospitals and veterinary clinics. We did a lot of housing for the elderly. I was pretty lucky. You know, I walked in the door. They were real busy, and they had an office building and a warehouse complex, and they said, hey, do it. Just do it. So for a graduate architect to walk in and be able to just take a project from design, programming design, working drawings, the whole bit was pretty exciting. But after a while, I decided I felt there was more to it. I didn't like the constraints I felt in an architectural office. What I should do, I think I can turn these slides on because I want to show a few slides of the college thing. Let's see this. Try that one. I always like nature. We always talk about man-built environments, but the best environments are always nature. Remember that house, Harry? This is in the 60s, so we have our love poster up here and our dartboard. And we used to have jokes. How do architecture students get their kicks? Think about it. Ask me at the reception what some of our answers were. Oh, man, that's 1970. Okay. Harry looked worse. This is my cool motorcycle. Harry asked me if I rode it. I still have a BSA. But anyhow, this is my old thumper. And if any of you did research, you should have done research on people coming. What's this? See, you didn't. That's my thesis project. What was interesting at that time, we had a wild man we called Bill Braswell. And Costello's back there laughing. I saw you come in. But what was interesting, Bill's thesis project was a housing development on an island. And at the time, environmental design was kind of a vogue thing at the time. And it got us into really thinking about environmental issues. And is Marv here? Yeah, there you go. Marv has been converted. It took him a long damn time, but we got Marv converted. But it really got us all thinking, because there are two kind of themes going at that time: environmental issues in design and behavioral issues in design. And we all took, what was the name of the psychologist, professor? Yeah, Whitney Gordon, his class in psychology. But in any case, it was heady times, and this is just to show you that I did actually do a thesis. I went next to, I decided I had to take a different path to get where I wanted to be, what I wanted to do. And I decided to go to graduate school. And the criteria for graduate school were, they had to pay me to go, I didn't have to take any entrance examinations, and I could do any damn thing I wanted to do. I thought those were pretty reasonable criteria. And so I was married at the time, and so Sue and I packed up a sleeping bag and a tent, and we drove around to check out some schools. And we went to Wisconsin, Manitoba, McGill in Montreal, and then we were driving back into Buffalo, New York in the pouring rain. And Sue said, I got a bad feeling about this place. I think we're going to end up here. And lo and behold, we did. But it was an interesting graduate school because it was interdisciplinary. There was only 20 students from all kinds of walks of life: planning, English literature, biology, whatever. It functioned as a research institute. There were 3 or 4 associated organizations with the school where all the students were assigned, and you basically did contract research that was funded by Department of Housing and Development, National Institute of Mental Health, whatever it was. We had one project where we helped the Seneca Indian Nation figure out how much to charge the citizens of Seneca, which wholly exists on an Indian reservation, how much they should pay lease for the next 100 years. Strange stuff. But what was interesting is they did pay me. I didn't have to take an entrance exam, and I could do anything I wanted. So it did exist at the time, and maybe it still does. I don't know. But it gave you a chance for exploration. So it was another idea of how can you improve your thinking ability and problem solving. And while environment and behavioral issues were big back in the late 60s, early 70s, in the graduate school it was systems theory, systems thinking. How do you think how elements interacted, and how to really problem solve. Very sophisticated ways, both quantitative and qualitative. And so a whole new kind of world opened up to think about architecture and design from a different kind of perspective. So in graduate school, we really got involved in performance again. We tried, who knows the requirement for egress from an office building? Uniform building, you guys are BOCA, right? BOCA? Uniform building code. How many feet from a point to a fireproof means of egress? 150 feet. Where did that criteria come from? It came from an engineer at the National Standards, what am I saying? National Bureau of Standards, how fast he could run holding his breath in a smoke-filled corridor. That's where a lot of the codes and standards that you will have to design to come from. They come down from generation to generation, or empirical things, and that's how they develop. What we were trying to explore, and this is with Charlie Masterson, we were actually, and Tom Tiedemann, we were trying to simulate the performance of buildings, and fire is one thing. That is, how, if you had a fire at different points in the building, how many people would die? Pretty heavy-duty stuff. And so, because if you think about it, what you would like to have in a performance code is that a fire could occur any place in the building and everybody gets out safely, right? That should be the design criteria or the regulatory criteria. How do you determine that? So we were trying to figure out ways, again, this is back in 1972, 73, on mainframe computers, trying to figure out how you simulate human behavior in a building during a fire event. Okay, just different ways of thinking about architecture, building performance, you know, kind of different than just, quote, pure design. We also were working on mental health planning kits. How do you decide what's the best solution to a community mental health problem? Assuming there is one. But let's say that the demographics and the data says there is an exorbitant amount of mental health in a neighborhood or community. What do you do about it? Is the answer build a mental health clinic? Is it an answer you have somebody roves around and talks to people? Is it a recreation center where maybe they can recreate and not have so much stress? So it gets you into thinking differently. We were talking at dinner tonight about architectural programming and how important that is to the design process. But that many times the programming process is designed to end up with the result being a building, the answer being a building. And many times the answer may not be a building. And are you prepared to deal with that answer? It have fundamental implications on your career and your ability to, if you remain an architect doing traditional architecture, whether you have a commission or not. But maybe you do something more important, that is solve that problem. From graduate school, I worked for the National Bureau of Standards, and I worked in the Office of Codes and Standards, and we were doing all kinds of crazy projects. You're trying to round up all the big city commissioners and help them think about improving their building codes to make them more performance-based. The head of the architecture school at SUNY at Buffalo left and started AIA Research Corporation, which was a mechanism to get the architectural profession involved in research. The building industry is very fragmented. There's not the research that's done. It's usually done by product manufacturing firms, you know, Ledex, Pella, so on. There is really not a national buildings research program and facility. And that's unfortunate. John Eberhardt's vision was that the architectural profession ought to be looking at some of these other issues that influence architecture and making available information that will help the profession create better environment. So I went there and had to deal with issues of floodplain construction. Seems like a contradiction in terms, right? You got a floodplain. Why do you want to build there? Well, a lot of people do, unfortunately. And so we got involved with how to think through the planning and how you can mitigate the potential for disaster for folks that do build in 100-year, 500-year coastal and riverine floodplains. We also got heavily involved. This is prior to the oil embargo of 1972 that none of you remember, but that's where the kind of energy thing took off in this country. When the oil embargo hit and there were gas lines a mile long, and the government finally realized how dependent this country was on foreign oil, then there was started a huge energy efficiency and renewable energy program. So I was fortunate enough to be there to participate in doing a lot of the research that led to a number of things. Wrote a book called Solar Dwelling Design Concepts that looked at the impact of architectural impact of energy efficiency and solar energy in housing design. And that's kind of got me in some of the energy environmental areas that I've continued in to this day. But it was a really interesting time. When Stu and I moved from Buffalo to Washington, that was just the same summer that Nixon was being impeached and left office. From AIE Research Corporation, they had started, the federal government created a national laboratory on solar energy called the Solar Energy Research Institute. So I was asked to come out and start a buildings energy research program, and that was my next almost career, really, was to go out and think about what research needed to be done to create a knowledge base that would help designers and builders design and build more energy efficient, environmentally responsive construction projects, residential and commercial. So at CIRI, we did all kinds of nifty things. We started looking at how do you daylight buildings? How do you purposely take daylight and get it into the building in a usable way so you can turn off electric lights? So we built test chambers and did research on all kinds of methods. We also looked at how do you build more energy efficient houses. We built and tested a number of houses all over the country, passive solar homes. We developed software. We did all kinds of things. Ronald Reagan got elected, and that kind of all came to a screeching halt. But one of my first projects at CIRI, let's see if this is the next slide. That's back. Let's see. Here it is. Was to go to Saudi Arabia. Is that focused? But I was part of a negotiating team for a $100 million cooperative solar energy program between Saudi Arabia and the United States. And here I am in my three-piece suit. You missed, I took off the vest. Out in the desert, it was about 120 degrees. Really stupid. And with my guide here who's dressed appropriately. But what was interesting, what I really learned is the value of indigenous architecture. They had a history. Uh-oh. Somebody check that. They had a history, well, the slides we're going to show, of some indigenous architecture that was very environmentally responsive. And it had been built up over many centuries of living in this very rather hostile climate. And because of the wealth that the oil that they had in the ground created, they were able to kind of throw away this traditional approach to their own design and build Western-style buildings, which immediately failed. Okay, architecture is about performance. And why did they fail? Well, they didn't have the infrastructure to maintain that technology. If you have central chillers and other types of plants. How bad is it? Pretty bad? Okay. Well, if you can go to the next one, just go to the one right beyond that. Unless you can save that one. So what I'm going to show you eventually is this high-rise building that the central chillers break down. They basically kick out the windows, put in unitary air conditioners, because they can just put them in, plug them in, and have some cooling. And then when those fail, they haul them out to the desert and throw them away. And so there's mountains of these unitary air conditioners rotting in the desert. Any luck? No luck. This is one of those close your eyes and imagine that. Okay. Well, when he gets that ready, we'll come back to that. The other thing that we did at SURI was try to develop evaluation methods. This is something you all should be concerned about. It was like, say, when you build your building and you walk away from it, how do you know if it's really working the way you intended it to work? How do you know the people are happy? What do you do to see if they are happy or if the building is performing in terms of the way it's supposed to perform? So we were investigating different ways of doing that type of evaluation, both on the technical side and on the what's called post-occupancy valuation, on the people side of the equation. No luck? Okay, we'll just move on. So SURI was a pretty interesting experience for me, and again, it has to do everything with architecture, but very different than traditional architectural practice. We would involve all the same behavioral and physical design issues that you have to be involved with to design good architecture. Reminds me of Bill Caudill quote. Bill Caudill started a firm called Dill, Rowlett and Scott that then was bought out by HOK. But he says you get good architecture by having good architects. So that's why it's important for you folks all to be good architects. So we get good architecture. Lastly, I left the Solar Energy Research Institute in 1982. And with my partner, Don Fry, we started Architectural Energy Corporation. And we wanted to do applied research and development in the areas of energy, environment, and buildings. And since that time, we've been undertaking a variety of projects that synthesize our kind of concerns for energy and environment. But it's really quite diverse. We have a sustainable design practice, and I want to show you some examples of some buildings, because this is a school of architecture, and I feel responsible for showing you some architecture. So I'm going to do that. Some projects we've been involved in as the sustainable design consultants. But also we've been doing things in commissioning. That's a term you hopefully are starting to hear around the school, which is project gets built, the door is open, is the building going to work the way you designed it to work? Commissioning is the process to ensure that that happens. Think about it. You as the architect working with the design team, the engineers and other consultants, you have a design intent. You're designing this building to have a certain kind of performance. Okay, and you represent that performance in the construction documents you prepare, plans and specifications. Those are given to the general contractor who works with all his subcontractors. Their job is to faithfully implement the construction documents, right? They're supposed to build it the way it's represented in those construction documents. Okay, so they build it that way. Who's the one responsible for the performance of the building? Any answers? Yeah, who's responsible? Well, who knows? It's really a big question mark right now. The architect is working on behalf of the owner to be sure things get done the way they're supposed to get done, but that doesn't necessarily the performance that you have intended is actually being achieved. So there's a whole new world called commissioning. That's another alternative career path you could take, is to be sure that the building systems are operating the way they're intended to operate. That means that the dynamic performance of the building is proper. That is, that the curtain wall systems perform, that the HVAC system performs as intended, the control systems, the lighting, all that stuff works. So when the owner opens the door and is occupying that building, they don't have to be the guinea pigs to basically get this building working properly over the next year and a half during the warranty period. So commissioning is another area that we do a lot in. It's a great alternative career path if you have an interest in that area. We also provide what's called energy saving performance contract support. It's too complicated to get into, but basically it's third-party financed energy efficiency improvements. I'll stop there, but ask me at reception. I'm kind of probably running late. We also do building science R&D. And it's, again, another great career path if you have an aptitude to research and very innovative problem solving and idea generation. We do a lot of performance monitoring. Bob mentioned some work we've done. This is another, I guess, career path you could take. One of the projects I did, it's probably about 7, 8 years ago now, is help design a battery-powered data logger. Anybody know what a data logger is? Logs data, right? But you have to understand the paradigm before was if you wanted to monitor this building and you wanted to know what the temperatures were in the different studios and in here, and you wanted to know the status of the air handling unit that's delivering air to the space, and you wanted to know power consumption or the gas utilization, you would have a central data logger, let's say you put it here, and you would run wires everywhere to get to the sensor that tells you temperature, humidity, airflows, power, and so on. Well, we had done a lot of that wire running around in Siri and AIARC and in my early business. And we said, this is crazy. So we had to invent a device that would collect that data easily. So we invented this micro data logger, which you can plug in different sensors modules into it and then place it at the site you want to take data, whether it's the chiller, the boiler, the air handler, or whatever. And it would collect that data, all time synchronized, because you could put 20, 30 of these around the building, bring all that data back, bring it into the PC and analyze the data and understand what's going on. So we developed the specifications, electronic design, and I designed the packaging for this product. So, I mean, it's another career path. You can be an industrial designer, package designer if you want. So, again, this is the idea of architecture is about performance. How you can predict it during design, how you can evaluate it after it's constructed. Both are equally important. Wouldn't a lot of you like to know this last project you designed, how that thing would really work? And I'm sure you're working with some of the simulation tools that Cirrus has. I hope you are. Some of the tools you have to actually simulate performance. Anyhow, so we do a lot of this product development, and that's certainly another area. I know a lot of architects that are now in the equipment manufacturing industry, be it with American Standard for toilet bowls or furniture or whatever. There's lots of opportunity for architects to help design products, be they furniture systems or be they architectural products, glazing products, all kinds of components that go into making a building. All of those represent tremendous opportunities for architects, architectural careers. Okay, are we up and running yet? Which one, the left side? So I got to push this button. Okay, let's try it again, folks. I guess you can just jump, you can really jump right over the top of that if you need to. I just want to run through these slides and then I'm pretty much, I'll have a few concluding remarks. Any questions you have right now while we're waiting for the slide projector to work? No? How long do these things usually take? 1 hour? Hey, I'm right on time. Architectural Energy Corporation is 40 people, and how many architects are in there? People with architectural training are by about 3 or 4, primarily because there's not that many folks that can do the kind of stuff we do. So hopefully more of you will take this path and there'll be more architects. Yes? Okay. The question was, what is the kind of work we do now? We essentially are 40 people with offices in Boulder, near Chicago, and we had a project office just till recently in Bangkok, Thailand, where we're doing a project, load research project for the Thailand National Electric Utility. We're organized into a number of business areas, and those business areas are what we call sustainable design. That's where we're hired by architects or building owners to help them design energy-efficient daylit buildings. So that's one area of the business. Second is commissioning. So we were hired by building owners to commission the building, make sure it's working properly. And we're working on a number of school projects now with the school board. School districts are hiring us to help them make sure that new schools and renovated schools are operating properly. We have a group called ESCO, or Utility Engineering Services. We're working with electric and gas utilities to help them implement energy efficiency programs within their utility service territory, or helping them do what's called market transformation. How can we improve the energy efficiency of the building stock within their service territory? We have building science R&D, where we're doing contract research and development. We just won a very large contract with the California Energy Commission to help create new fault detection methods and look at building integrated photovoltaics in buildings and a whole variety of different areas on it for research purposes. Then we have contract research and contract product development. Companies hire us to create software. Like that thing I mentioned about Gas Research Institute, they hired our firm to create this DG Pro software. Or we've been hired by another company to create a new data acquisition product. Then we have product parts of the business. The REM rate software Bob mentioned is a product we have, which is a home energy rating software that's used in over 40 states for rating the energy efficiency of homes, which allows you to obtain energy efficient mortgages. So it's a way to leverage your money through the efficiency of the house you live in. We also have a software called Informa, which is for diagnostics and commissioning of HVAC lighting and control systems. We have the microdata logger you saw. We manufacture that and distribute that. And then we have the DG Pro software. So those are the business areas we have in the company. And our clients are national, international. We work all over the place. Okay, you going to try this again?
Let me do it.
Yeah, why don't you? Yeah, okay, good idea. It's going to.
Turn the lights out.
Okay. Just hey, Sonny, just skip over it. Just go to the building slides about 3 back from that. See if that works. You think it's the tray? It is a tray? I've used that tray before. Anyhow. What we might do is, if it's a tray, then forget it. I'll have to, I'll do a performance tomorrow of the slides if you're interested. We can get a space to do it as part of your enrichment week. I don't know. Well, it's up to Carol, so we'll... Okay. Now, I've been trying to think about conclusions because most of this stuff, it's just easy to talk about because it's just more experiential from my point of view. But I guess the question is, what can you say about architectural education as a starting point for alternative career paths? That's the first. That'd be a big question. That'd be worth asking in enrichment week. First is, it's an excellent education, basic education, because of those 3 different skills area I mentioned before: fundamental knowledge, process knowledge, communication skills. The education you're getting is going to be extremely worthwhile for whatever you want to do, and it actually will give you a leg up on a lot of others who come up with, I won't say anything, I'll offend somebody, but it gives you some hard skills that you don't necessarily have to use in a traditional sense. And that's what I hope you can kind of see in my presentation tonight that you can take the skills and knowledge you have and use them in a very different kind of way. All of them are very important, and all of them contribute to the betterment of the built environment. Oh man, I'm not going to, okay, I'll try it. Well, let's see if it works first. Okay, it did work, okay. Remember I told you the high-rise with the windows kicked out? There it is. And see the unitary air conditioners? And that all happened because there wasn't the infrastructure. Chiller went down, nobody's there to repair it. Kick out the windows, put in unitary. And then this is the follow-up slide of the dump of all the unitary air conditioners. This is actually the small pile. I could have a whole other discussion of appropriate technology. Okay, I promised you some architecture. Okay, here goes. This is the Boulder Public Library. This is a mid-'80s project that we did with an architectural firm in Boulder. The shape is driven by a floodplain, and you couldn't build below that, so this round shape has to do with that. Plus, it's facing northeast, so you can go a lot with very clear glazing. Aggressively, the city of Boulder is very interested in environmental design and sustainable design. Just another look at it. This is the stack space and the reading space, the second floor. The idea was to create the sense of the clear stories, and the ceiling surface between the clear stories is clouds. Get the light from the windows onto the underside of the clouds. Indirect lighting. Another picture. We did tons of conceptual models. That is, think about it. What's it mean? What is the physical form implications of daylighting space? How do you introduce light, and how do you get that light where you want it so it can serve a useful purpose? So we did a number of just mass models looking at different ways of introducing light into space. So we did all those things. And then we were actually, at the same time, we were running an energy simulation to look at the energy impacts of different types of integrated systems, the electric lighting with the day lighting, with the different mechanical systems, all that stuff, to see what the overall performance is, basically scorekeeping. And then we worked with the architect to pick out the glazings. There's about, I think there's like 15 different glazings in here based on orientation and the function of that glazing. Is it for vision or is it for daylighting? Vision glass has to have different characteristics than daylighting glass. This is a photo of Denver International Airport. This was a real fun project because we got to help to design it twice. The way they had this project set up is they had one firm that was going to do schematic design, pretty much through DDs, and then another firm was going to take it and then take it through construction drawings, construction supervision. Well, I'm sure you all know about architectural egos. So the building got designed, getting ready to hand over to the next firm. Next firm says, you can't design it like that. It's going to cost too much, and it's da-da-da-da. And so within a period of about 2 weeks, the whole thing got redesigned into this form. The previous form was a whole series of clear stories because the client was an office full of civil engineers. Hope I'm not offending any civil engineers. And all they wanted was a hangar. We call them the flatheads because all they wanted was post and beam and don't give me anything fancy. So the other architect, what happened is the city appointed a blue ribbon committee, praise the Lord, who basically made it clear that this is public architecture, and public architecture has many important reasons for being, some of them very symbolic. And so the next architect was Fentress Bradburn, Kurt Fentress. We sat down in his basement and we came up with this kind of design. And again, our role is to think about daylighting. I don't know, this is a fabric skin roof, obviously, but their initial idea was to really cover the whole facility in this roof. And you can see, I will, Sonny, need my pointer. So this is what we call vision-preserving glass. It's just traditional glass. This wasn't initially there until we made them get it, because if you've ever been in a space that's wholly covered by this kind of fabric skin is very monotonous. There's no sparkle to it. We wanted the ability for light shafts, direct beam sun, to come in there. And that's what we did with this and some light glass around the tower. Anyhow, if any of you have been through there, it's a beautiful airport, functions very well. We had nothing to do with the baggage handling. Okay. This is the Solar Energy Research Facility. This is in Golden, Colorado. And it's basically a photovoltaic research facility. So there's laboratory space dug into the hills. And then these two modules here are office space. Office modules. These two guys here and then here. And again, this is south sloping. And so you think, wow, that's easy. That's cool. You know, solar, south facing. But when you're trying to daylight and you have an open office situation with partition walls, it's very difficult to daylight because you have to control very carefully the direct beam solar coming into it. And so these airplane wing interior shelves here had to be fairly deep so you can control the sun angles. You can see this little sliver of light coming in. Because if you're in some of these spaces and that thing comes in and blasts you, you're going to be pretty upset. So we had to be real careful how we allowed the light to come in. This is Corporate Express International Headquarters in Broomfield, Colorado. And it's a fairly large building. I can't remember the square footage, but what's interesting is it's got basically two series of floor plates surrounding central atrium. And you can see the bands of glass here. This is basically daylighting glass and then vision glass. The daylighting glass is trying to be as clear as possible to get as much sunlight from the sky vault into the space. The vision glass, obviously, is to look out. But what you got to be careful of when you do that is the contrast ratio. You don't want that vision glass to be so bright you get disabling glare. So we had to be careful how we designed it. We ended up developing an optical light shelf system that has a Fresnel lens mylar coating that directs and spreads the light. So the sunlight is coming in and being reflected. This was a prototype. That's what this is a slide of. In actuality, you can see it installed along here, and it throws the light 45 feet deep into space. And our daylighting invention is basically taking this kind of concept of this optical light shelf and making it smaller, like a mini blind concept. Call it a mini optical light shelf daylighting system. This is a project that's just getting under construction. This is the Denver U.S. Federal Courthouse project. It's a HOK, Anderson Mason Dale project. And again, we're the sustainable design consultants. And this is to be a showcase project for GSA and the courts on sustainable design in federal facilities. And it consists of an office tower and then a special proceedings and entry facility. Using, again, kind of a light shelf technique to get light into the space. Another interesting concept we're using is displacement ventilation. It's a concept you should learn more about. It's a way of introducing space, air into the space low, taking it out high to preserve and enhance air quality and reduce energy consumption. This is another example. We're trying to do some daylighting in the actual courtroom space. This is that displacement ventilation, where you're basically bringing air in low. It's a plug flow, exit it high. Typical strategy used is throw it in high, take it out high, and it's a mixed space condition approach. And you can get pretty bad pollutants if you're not careful in how those diffusers are placed and the airflow rates. And you can see the energy performance of that courthouse for a minimally compliant design. Federal standards would be $250,000 a year, and the final design gets it down to just a little above $100,000. And these are the techniques we use to get there, and I won't go into those. But now, this is probably the final slide, I think. But what's my philosophy of architecture? Okay, there's a good slide that says why. if you look at the cost per square foot of an office space, $130 a square foot is related to the salaries of the people in that space. Look where energy and some of this other stuff is. It's down in the noise. If those people aren't happy, you get pretty lousy productivity, and you're not going to be very successful. It just points out very clearly that focusing on people is the way to go, as always in design. But you have to be able to do it in a way that you can understand and predict the performance, and then actually go back and see how you're doing. Commission it and monitor it and evaluate it. All those things represent alternative career paths for you on the design side. It gets into regulatory planning and all that other stuff. On the commissioning side and on the evaluation side and many other places. So, we are wrapping up. I'm extended. I'm too late. I think, at least I know in my case, and I hope it's true in your case. I mean, again, I don't know enough about the education you're getting here, but I've heard good things about the graduates from Ball State. And I know a lot of the faculty, and I know they're good people, so I hope you're getting the same quality education that Harry and I and Rod and others have over the many years at Ball State. But there's lots of opportunities for you to use your education in different kind of ways. And you shouldn't be afraid to do that, because all those ways will likely contribute to improving the built environment. And having that as kind of the thing that motivates you is really the key. You have to have some altruistic reasons to do things. Obviously not in architecture for the money, I'll tell you that much. It's tough to make good money in architecture. So you have to have a variety of reasons that you're here and what you want to do and how you want to use those 3 skill areas that you are developing and acquiring while you're here. So anyhow, thanks for your time. I'm going to be around through probably Saturday noon or after lunch or something. I want to hear John talk. So if you want to get together, or if you want Carol or Bob to organize a special session to talk more about this stuff, I'll be happy to do that. Otherwise, I'm going to say it anyhow, get your butts to those enrichment programs and get your head into it. You'll learn a lot. You'll look back on these opportunities provided you as nuggets that will enrich your lives for many years to come. Thank you.